Question 1.8 requires us to rank the solutions from lowest pH to highest pH and then select the answer which matches. We have 4 aqueous solutions of these compounds and they are all of equal concentration. Now pH equals the negative log of the concentration of hydrogen ions. So a high concentration of hydrogen ions means a low pH. And a low concentration of hydrogen ions means a high pH. So we need to figure out the relative concentrations of hydrogen ions in each of these solutions to be able to compare their pHs. Strong acids dissociate fully in water and produce a high concentration of hydrogen ions. And weak acids dissociate partially, forming an equilibrium with their ions, and so produce a lower concentration of hydrogen ions. Strong bases dissociate fully and produce a high concentration of hydroxide ions, while weak bases dissociate partially or actually react with water to produce a low concentration of hydroxide ions. Nitric acid is a strong acid, so it dissociates fully and produces a high concentration of hydrogen ions. A high concentration of hydrogen ions gives a low pH, much less than 7. Carbonic acid is a weak acid and dissociates partially, forming a low concentration of hydrogen ions. And so its pH is still in the acidic region, but it is weakly acidic, and its value would be higher than that of nitric acid, but still less than 7. Now ammonia, which is actually a gas, reacts with water. We could write the state symbol as aqueous as given in the question. Ammonia reacts partially with water to form ammonium hydroxide, which dissociates partially in solution into ammonium ions and hydroxide ions. Since an equilibrium is formed and the dissociation is partial, ammonia is a weak base. It forms a moderate concentration of hydroxide ions, but we need to know the concentration of hydrogen ions to get the pH. Now, regardless of what solution we are talking about, any aqueous solution or pure water has some water molecules undergoing autoionization. The equilibrium constant for water is the ionic product constant of water, and it is a constant value regardless of the concentration of hydroxide ions and hydrogen ions. If the concentration of hydroxide ions is high, then the concentration of hydrogen ions is low, to keep Kw a constant value. And if the concentration of hydroxide ions is low, then the value for hydrogen ions is higher. Since ammonia solution produces a moderate concentration of hydroxide ions, the concentration of hydrogen ions is lower than pure water. And so the pH is weakly basic. Lastly, sodium hydroxide is a strong base and fully dissociates. It produces a high concentration of hydroxide ions, which means the concentration of hydrogen ions is low. In turn, the pH is very high. The order of increasing pH is nitric acid, then carbonic acid, then ammonia solution, then sodium hydroxide solution. So B is the correct answer.